Hello and welcome. I'm James Murphy, and today we're going to be covering a viewer-submitted question. Given a list of integers, how do you find the maximum sum of any increasing subsequence in the list? Now, by increasing subsequence, I mean that the values that we take have to be increasing. So for this list, the biggest sum that we can get is 6 plus 7 plus 200. So you can see 6 is less than 7 is less than 200, and you can tell the list is not sorted in this case. In this case, we can just take all of the numbers since they are in increasing order. And by convention, we'll say that the sum of an empty list is 0. To start off, let's just make a function that computes the biggest sum and not worry about keeping track of what the actual integers that make up the sum are. We'll get to something that keeps track of the integers later. So just by convention, if the list is empty, then we'll just say that the maximum sum is 0. Well, this is a kind of problem that you can split up into a very similar subproblem. So let's make a list max sum, which is going to represent basically the answer to the question if you have to end on index I. So for each I, let's start out with 0. 0 for unused variable in sequence. And then let's go through and successively fix up the max sum. So the biggest sum ending on some index I has to be made up of whatever is at index I plus some previous biggest sum. Now, that previous biggest sum is going to correspond to some index j before I. This is basically saying that when I have a sum of numbers, I just break it up into the last number and then all of the rest of them. So this would be the last number, and then if I have all the rest of them, well, that better be a biggest sum ending at some previous term. Otherwise, I could have chosen something bigger, and then this would be bigger. So let's just go through and iteratively figure out what the max sum ending on index I has to be. So let's say for I in range of the length of the sequence, then I'll start by getting whatever the max sum is for all the previous terms. So let's just look at for j in range I. Let's make the max sum at I equal to the max of the max sum at I and the max sum at j. But we don't just look at any previous sum. We're only allowed to use a previous sum if we can preserve the increasing property. So if we're going to be adding on the ith element, then that means the term for the previous biggest sum corresponding to the jth element has to be smaller. So we only do this if the sequence at j is less than or equal to the sequence at I. So basically, we're finding the max of all previous sums that we can extend by whatever's at I. So this little loop computes for us basically what is the previous biggest term that's allowed, and then we just need to add on sequence of I to that. So then we'll just say max sum of I plus equals sequence of I. And then at the end, we know that the biggest sum of all is definitely the biggest sum that ends at some location. So let's just return the maximum of our max sums. And let's go ahead and run it and see if we get the answers that we're expecting. So indeed, we get 0, 213, and 38. So that's a pretty quick and dirty implementation. We've got a double for loop here. So this is going to be big O of n squared in time. And we're using some extra space here. So this is big O of n extra space. This is not necessarily the fastest or most efficient thing you can do. Since we are using n squared time, it might actually be faster to do something like take the sequence, read it into a NumPy array first, and then do vectorized operations, things like that if we actually were really worried about performance. But I think this big O time complexity is about as good as I can get without doing anything too tricky. So let's just stick with that. So I'm basically happy with the algorithm that we used in order to compute the maximum sum. Now I just want to say, okay, I know what the maximum sum is. What are the numbers that actually add up to that maximum sum? So I basically want to keep the exact same algorithm, but somehow keep track of all of the numbers that make up these max sums. So what I'm going to do is make a new function, and I'll just call it the same thing with elements. And so this time, instead of just returning the sum, I'm actually going to return, let's make a new class to contain this information. So let's call it, let's say, ints and sum. So the whole purpose of this class is basically just going to be to keep track of the lists and just do all basically the same operations, but have the class keep track of the numbers that are underneath it. So my ints and sum is basically going to be, well, it's going to take in some ints, and let's just say that's a list of int. And I am using Python 3.9 here, so I've got the lowercase list. If you're running this and getting an error, just go ahead and remove the type annotations if you're not comfortable with that. So I'll just say self ints equals ints, and then I'll compute the sum to be the sum of the ints. Then just so we can print things later, let's go ahead and define a repr. And let's just return, I guess the proper way to do it is to say self class. Not that anyone is going to be inheriting from this toy example, but it is best practice to do something like this. So let's just print out the name of the class and then the list of integers, followed by the sum. Okay, so now if we print an object that we make like this, then it will look nice. And let's go ahead and copy these. Okay, so that's ready. We can just run it whenever we're ready to run it. Now let's get to the actual code. So I'm going to try to keep the algorithm as similar as possible and just do most of my changes in this new class. So for starters, I'm going to be returning an instance of this ints and sum class. And I'm pretty sure it's going to be about the same amount of extra time. I'm guessing, though, that this is going to end up being O of n squared extra space because we're going to be keeping track of those ints, whereas before we just had a constant thing in the max sum. Now we're going to be having a variable thing in the max sum whose length is at most the length of the sequence. So I'm guessing that's going to be an O of n squared. Okay, so if we're given an empty sequence, what do? Well, we want to return kind of the empty ints and sum. So my ints is just going to be the empty list. What else do we have to change? Again, anywhere I have 0, I'm just going to replace that with an empty ints and sum. And this can stay the same, this can stay the same. The sequence doesn't change. Okay, so the next thing that is going to be a problem is what's the maximum of 2 ints and sum? Well, I'm just going to basically write a method that computes the max, and it gives you back the first one that has the biggest sum. So basically ignore the ints and give me back the one that has the biggest sum. And I'll just make this a class method, or actually a static method. It could just be a freestanding function, but just due to the nature of the function, I think it's appropriate to just put it inside the class. So let's just define the max function. And let's see. So here I have a max of 2 things, and here I have a max of an iterable of things. So I think I'm going to structure this using a variable number of arguments. And what I'll do is just return whatever the Python built-in max of those args does. But again, since I'm passing in these ints and sum classes, the built-in max doesn't know what to do with that. So I need to give it a key to tell it how to determine which thing is bigger than another thing. And I'll just say my key is given an ints and sum variable x. The thing that it should be using to decide which is bigger is just x.sum. So then here we can replace this with the static method in sum max of these 2 things. And the other thing, and we can also go ahead and replace that here. And then the last thing that we need to do is handle this plus equals operation. So I need a way to append a number to my list. So let's go ahead and add, let's say, an append method. I'll take an integer I, and this isn't going to return anything. We'll just go ahead and take the integer I and append it to our list of integers, and then increment the sum by I. So here, I need to go ahead and not plus equals, but I need to append this number sequence I. Okay, there's one small thing that I see that is going to give us the wrong answer, but let me go ahead and run it so that you can see that it's not doing the right thing. Oh, list has no attribute sum. That is because I am passing in this. I want to pass them in one at a time. So in this case, it does look like we're still getting the same correct answers, but I have a funny feeling about this one. So I'm going to go ahead and I'm pretty sure this is broken, and let's just go ahead and fix it, and then I'll hopefully be able to find an example afterwards. So the issue with this is the built-in max operator is going to be returning to you basically the one of these things that's the biggest. So it returns to you the actual object, not a copy. So that means this max is going to be a reference to a previous object. So I'm going to be putting in max sum location I some previous max sum location j, and then here I'm appending to that. So if the answer was supposed to be that previous location j, then I've just messed it up by adding something into it. So this is a little bit tricky to see, but whenever you're using references to lists, make sure to copy things whenever you don't want to change something that's supposed to be a constant. And in this case, I know I have this max sum j, which may be assigned into max sum I, and I don't want that to be modified because essentially my loop invariant, I didn't write it down here, is that max sum I is fully computed and going to be constant after the ith iteration. So appending is going to violate that loop invariant. So I'm not sure that I have a counterexample right off the top of my head, but I'm almost certain that this is broken. So let me go ahead and make a copy at the correct place. So here, I'm not doing any modification, so I don't need to worry about it. The only place where I'm modifying a list is right here. So here's where I need to make the copy. So let me just say max sum I is going to be max sum I dot copy, and then I just need to define a copy method. So let's say copy self, and we'll just return a new thing, instance sum, where we have the ints just be our self.ints.copy. I guess I didn't type hint this. This should be a list of int as well, and this should be a sum. Sorry, this sum should be an int. So this is a list that has a copy method, so let's just make that copy. And then it's not really going to make a big difference in this case, since these are such small lists, but maybe just because we have already computed the sum, let's just take in like a pre-computed sum. And this will be the pre-computed sum if it's not none, otherwise then compute it. So it's a little bit of a mouthful, but so by default, nothing is passed in, and this will be none. And so I'll just compute the sum of the integers passed in. Otherwise, in this case, when we're making a copy, then I'll just pass in the pre-computed sum to be whatever the current sum is. And let's go ahead and run it again. And you see that it's still giving me the same answers. Okay, so I went ahead and I finally found this example. And as you can see here, when I comment out this copy line, you see that the sum is ending up to be 77, and it's supposed to be 34. And maybe I'll even debug this for you. So let's go ahead into the debugger and see what goes wrong here. Yeah, so in this case, I'm looking at index 4. So 10 is the index that I'm looking at. And of the things that are less than 10, the one that's going to have the biggest sum is this 8. So 12 is too big. I could have a 4 plus a 2, but that's smaller than just taking the 8 alone. So in this case, I'll have the 8. So the thing from index 0 is going to be the maximum. And we see it finally exits. And then I go here and I append. And you can see I just appended the 10. But now you see what I had at the very beginning is wrong. This 10 now appeared in the max sum at index 0, when actually I only wanted to add it at this location here at index 4. So that's why that's going wrong. And if I make a copy, then this list and this list are going to be different lists, so I can append to just this one without affecting this one. So if I go ahead and put the correct copy back in, you can see that now I do get the correct sum of 34. Well, I hope you enjoyed this little problem. If you did, or if you have any other problems that you'd like me to look at, give me a like, give me a comment, and if you especially like the video, don't forget to subscribe. Thanks for watching.